Hi, everyone. Our project is called Ingenuity, Martian Drone Simulator. Ingenuity means being clever, inventive, resourceful, and imaginative, which connects directly to our project. Our simulator is designed to help scientists and engineers test how spacecraft or drone systems could perform in space-like conditions before being used in real missions. Our simulator focuses on recreating some of the challenges a drone would face on Mars. Since Mars has a much thinner atmosphere than Earth, flight is much harder and requires careful planning. Our program simulates drone movement, takeoff, battery usage, wind drift, obstacle detection, and telemetry data. The goal is to create a simple but interactive way to understand how a drone might behave in a Martian environment. This connects to the real NASA Ingenuity helicopter, which was used to test powered flight on Mars. In real space missions, scientists cannot just control a drone instantly because there are delays, environmental risks, and unknown terrain. Our simulator shows why autonomous systems are important. It gives scientists a way to test commands, movement, and mission conditions before sending technology into high-risk environments.
Oh, you're recording. Hi. So I'm going to explain the code first before I go into a full demo. So we use just the standard libraries. We use the turtle library, which is just going to let us show like the spacecraft like moving around. So first to explain the code, we set a class where it's a width and height, so that's like the border of our screen and the colors and whatever we want for the ground and such. We defined all the variables that will be later used, such as time and all of the movements. After defining all our variables, we created the obstacles, which are their own variables, which the turtle can hit. We use conditional statements here, so like if the person moves forward with W, then they move forward and such. Now we did that for all the commands and inputs. And define more variables, which were later used. And that's pretty much just it. It's just conditional statements, variables, a few loops. The loops are just like for the repeats of random, like all the random things for when we import a random. And that's pretty much it for the Python. HTML, it's not necessarily logic based, so we just defined what our background was, we defined the colors, and then when you go down, we explained all the text, which are just headings, paragraphs, so it's pretty simple. So I'm going to actually run the code. So you can either run the Python file, but we did an extra step just to make this a better. This is our actual program. So originally it was just a Python file, but to make this better product to actually send to NASA and whatnot, we made it an executable. So that's our drone, and these are all the obstacles, and this is basically simulating all the conditions, so all the physics were used. And up here in the top left, there's a log of all of the data that scientists would need after testing their stuff. So first they can take off, and it's right now simulating the gravity on Mars, which is 38% of Earth, so there's a lot of changes. So you can move forward, you can land, they can test everything. And then there's something called auto mission, which actually uses AI to simulate what the mission is, and it calculates how many samples they collect, how many events happen, wind drift, and the position and whatnot. So it's a pretty useful tool for scientists.
Our simulator includes both manual controls and an autonomous mission mode. The drone can take off, move forward, scan the area, return home, land, and recharge. It also tracks real-time telemetry, such as battery level, altitude, mission status, wind drift, distance traveled, and collected samples. We built it using Python, Turtle graphics, tkinter for the controls, and Pillow to handle the drone images and animation.